Hello, welcome to lecture 34 of game theory course. We were in the middle of talking about the Red Sox and its agent player Otis. We are assuming that Otis has risk-averse utility function. W is the wage and root is the utility function. And I explained if Otis has two options, getting $1 for sure or $2 with probability of zero, with probability of 50%, zero with probability 50%, and which would he like? He would like the $1 for sure, because if you put it $1 here, that will be one. On the other hand, if you put 2, it's 1.4 something, and 0, it's 0, so half of 1 point something plus half of 0 would be 0.7, so 1 is bigger than 0.7. That's why he would be risk-averse person. The same average, but without risk is better than with risk. Okay, so Otis is agent with risk-averse utility function. If let's assume that Otis' current wage is $1 million and he get it regardless of his performance. But what if Red Sox wants zero wage to be zero when the performance is low with probability of half? Okay, that means Red Sox is suspicious that Otis is not doing his best. So they want to kind of punish him by giving him zero when his performance is not good. Let's assume that if Otis does his best, he will get a good result with probability of half and bad result with probability of half. So let's assume S would be the wage of Otis when he performs well with probability of half. 0 would be what Red Sox want to give him with probability of half when the performance is not good. Okay? The problem is when Red Sox ask Otis to change from $1 million to something like this, when your performance good is S dollar, performance is bad, $0, Otis should feel as happy as $1 million he's getting. This is utility from $1 million. This is utility from new contract with probability of half. So this new contract should be giving Otis a utility level bigger than or equal to the original level. Otherwise, Otis will not sign here. Okay? So what should be the S? In other words, minimum S that can make Otis sign the new contract. At the minimum, the left-hand side, the current contract, and the right-hand side, the new contract offered by Red Sox should be same. So root 1 million, which is 1,000, when you put root here, 1,000 should be same as half of root S. Root S should be 2,000. That's why S should be 4 million. So the conclusion is, in order to persuade Otis from changing the current contract where he will get $1 million at any situation to where he will get $0 when his performance is bad, that would be probability of half, and S dollar when his probability is good with probability half, then the S should be $4 million. Otherwise, Otis will not change it, or Red Sox enforce it. Otis will quit Red Sox to go somewhere else, like Toronto, New York Yankees or something, Toronto Blue Jays and things like that. He can move, certainly. This is a democratic country. So, what would be the problem then? Probably when Otis has this new contract where he knows that if his performance is bad, he will get zero wage in that year. Otis would try better, try harder. So maybe his performance would improve. However, if you think about how much Red Sox is paying, the original contract where Otis is getting $1 million for sure, he will get $1 million. In the new contract, however, Otis either get $4 million or $0 million. But the probability is half and half, $4 million or $0 million. As a result, on average, the expected wage of Otis would be $2 million. So it is one thing to give Otis incentive to work harder, but it is another thing that when Otis is risk averse person, averse agent, if you want to give an incentive to a risk averse person, you ended up paying more. In this case, twice more. So incentive will make Otis work harder. However, Otis will demand a higher wage because he has to take the risk which he hates. Think about that. When you become a government officer, you will be paid quite low. In Korea, the first payment would be like 30 million Korean won or 30,000 US dollar, 30,000. But if you go to a consulting company or if you go to become a lawyer, you would get paid 10,000, 100,000 US dollar or 100 million Korean won. So basically, you would get 3 times more if you become go to the consulting company or like a law firm instead of a government officer. But interestingly, many Korean young excellent student who would be able to enter all these high-paid companies willing to go to the government office by getting just 1/3 of what they could have gotten. The reason is if you go to this consulting company or high paid like law firm, you are going to pay well, but there is a good chance you will be fired in the next 10 years. They never hire someone for a long time. So you're thinking about, of course, when you're fired, you can get another job. But then you can assume that it is quite unstable. If you do not like instability, if you do not like the risk, taking the risk, then this private companies, high paid private companies, not the place you can go. Okay? So those people are willing to get paid like 70% less than what they can be paid and become a government officer. Okay? Because they are risk averse. On the other hand, when those people, the government officer people, if you want to hire them and you are a private company, then what does that mean? You have to pay them at least 3 times or more to get them out of the government office to your private company. Why? The private company is giving them not only the salary but the risk, which they hate. So you're basically asking them, okay, please come to our private company instead of that government. And they say, come on, I like stability, but your private company can fire me anyway, in any time. And you said, we may, but for that, we are going to give you this huge money. So like the private company giving the will make the workers work harder because they may be fired anytime. But then, because of this danger of getting fired, they ask you much more money because they not only do the job, but also take the risk which they hate most. So they should be compensated not only for the work they are doing, but also the risk they are taking, risk of getting fired. Okay? The question is, if you are a principal, like you want to make your agent work harder, but then that means you have to pay them a high payment. And you have to calculate, okay, making OTs work harder will increase my profit at the Red Sox profit. But then also that will increase OT's salary. Does that, the increased profit, can justify the OT's salary? If not, give it up. Let Otis be lazy and give him just $1 million. So principal can make the agent work harder, but has to pay a higher wage, as we see in the case of Otis and Red Sox. Is it worth paying the agent more if the higher effort of the agent would not increase the profit so much? It is better to let the agent be lazy. Okay? Actually, this is the key of principal agent problem. I mean, actually, agent is not so much cheating on principal. I mean, principal cannot see the effort, but principal is not a dumb person. He knows that agent will be lazy. And in addition to that, principal can fix it. How can he fix it? By give the agent a very strong incentive. If you work harder, you'll pay lots of carrots. But then the principal calculate all that, and wow, I have to pay him so much carrot and so much wage. However, his productivity would not be so much increasing, so I kind of gave up. Okay, something like that. As I said, with all this problem, the moral hedge principal agent problem is really far from getting solved. But I think in the future, if there's any engineer who can invent the checking the effort level of agent correctly, verifiably, he has a good chance of getting Nobel Prize in economics for solving this principal agent problem. Look at the Sherlock Holmes. I mean, Sherlock Holmes was a great detective, but I mean, he cannot be so much, famous nowadays because you don't have to, detect, and you don't need a, super brain and clever person. We have CCTV. I think the CCTV is much better than Sherlock Holmes. Sherlock Holmes gets something that is not a proof, but there's a average dumb policeman looking at all the CCTV. You found the criminals actually doing something on CCTV. Period. That is verifiable. Much, much, much better than Sherlock Holmes. So instead of we are needing the smart economists to solve somehow this principal agent problem, in the future maybe a brilliant engineer who invent measuring the effort machine, and just normal TA, normal student, normal high schooler can measure their effort level. Good. Of course, there's always danger. Somebody is hacking the machine. But okay, this has been I hope, a little bit difficult but entertaining stories about principal agent problem. Actually, what I have told you is the essence. If you understand everything, you can say you understand the principal agent problem. However, we didn't actually prove anything mathematically. It's it may be so kind of story. Logical, but not really accurate. So now we are going to be in the business of explain everything what I did for the last 3 lectures by mathematical example, real calculation, Lagrangian, differentiation, etc., etc., etc. You would be surprised how mathematical result is same as what we have seen. So I'm going to give you a mathematical example. There are 2 effort level, which is EL and EH. EH is high, EL is low, naturally. For the agent, the cost of high effort is 600. So when you exert high effort, it's 600. That's why the agent do not like the high effort. but the cost of low effort is zero. I mean, you are not working really hard at all. I mean, if you're a convenience store, high effort means you say hello and you just be kind to everybody who's coming and things like that and talk to them. Zero means, somebody came in, you just ignore them. Somebody said like, can you explain this? No, I don't know anything, kind of thing. Okay, so it's effortless. The reservation utility for the agent is 400, which means, like reservation wage I talked about, but then here it will be more convenient to talk about reservation utility. So the wage should be, in the end, big enough so that the expected utility by working for the principal should be bigger than 400. Otherwise, the agent, we call him Bill, will quit the job and go somewhere else. Okay. Somewhere else. When the agent is working for the principal, there can be 3 levels of profit. They are 1 million, 4 million, 9 million. Okay. Of course, 9 million would be best for the principal, in our case, Tom. The principal is risk neutral. I mean, the principal just maximizes the expected profit. It's not like necessarily risk averse, but the agent is risk averse. That's why, like OTs, we put root W as agent utility function. Okay. In order to be correct, I mean, the principal can be risk averse too. But then what is important is principal should be less risk averse than agent. If the principal is risk neutral, definitely that's less risk averse than risk averse agent. Okay. The agent utility from the wage is W, which is root W. The agent's total utility would be root W minus the cost of effort. K can be H and L. The cost of EH, we already knew, 600. Cost of C of EL would be 0. We already assumed that in the previous page. Okay, I'm going really fast, but then, as you know, you have time, you have this PPT in your hand, so read it over and over. If you don't understand it, rewind this lecture and listen to my lecture again, then I think in a couple of times you will understand everything. We need another matter. When the effort level is high, the probability that each result would happen are P1H means profit X1. Okay, we see here X1, X2, X3 are the profits, 1 million, 4 million, 9 million. And here P1H means when the effort level is high, the probability that X1, which is 1 million, would be happening is quarter. Same for X2, quarter, but X3, 9 million in our case, when effort level is high, is half. So the probability for $9 million profit is happening is biggest, that is half. When the effort level is low, it's the opposite. The probability that the lowest profit, 1 million, would be happening is half, and the largest profit, X3, 9 million, would be a quarter. So once again, when the effort level is high, the probability for 9 million increases, that is highest. When the effort level is low, the probability for the smallest 1 million would be half, biggest. That does not mean that still when the effort level is high, the smallest X1, 1 million, can happen. And even when the effort level is low, the biggest profit, 9 million, can also happen. Okay, this is God intervention, what I mean. Okay, So the effort does not guarantee high effort does not guarantee high profit. And low effort does not always bring in the lowest profit. Sometimes the highest profit is possible. So this is the end of all these setups. And if you look at this, from here, EH, EL, and 600, 0, reservation utility 400, and XC, the profit axis, and the probabilities, and the risk averse agent, etc. What we have talked about until now, the solution 1, 2, 3, 4 are in here. Okay, so if you feel that, I would be very happy you understand what is going on. Now, the economists are notorious in making many questions, but if you begin to think about economists, real economists, you have to ask two questions. Question number one, in ideal situation, which the economist dreams about, all economists, what would be the wage of W1, W2, W3? W1, what does that mean? If profit 1 million, X1 happens, what the wage? Of course, the wages are a function of the profit because, it's observable. But here, the ideal case is where the principal can observe the effort level of agent. Then, what would the principal set X1, W1, W2, W3, which is the wage when it is X1, wage when it is X2, wage when it is X3. And what will be the effort level of agent in this case? What will be the profit of the principal? Okay. Then we are going to move on to realist case when the principal cannot observe the effort level of the agent. What would be W1, W2, W3 in this case? And what would be the effort level? What will be the profit of the principal? So by thinking about this unrealistic ideal case against the realistic case, we can see what is the problem of the real situation. Especially when, that if the ideal situation result is same as real situation, we can say there's no problem in realism, in the real world. But if the ideal case result is different from the real world case, then we know that real world has a problem from economics point of view, and what problem that is. Okay. Here, I'm going to give you remind you, we are in the middle of subgame perfect equilibrium concept. This is application. Why is it subgame perfect? Think about that. Like how does it work? When I came to Yonsei University tell me we are going to pay you this much. When you enter a company, they may tell you, but even though they do not tell you, you know how much I would get paid. I mean, that would be a disaster if you think, oh, I'm going to pay like 50,000 US dollar a year, but then it turns out only 30,000. Then probably you'll keep the job. Okay, so basically the company make you sign the contract, and there, like kind of how much you are going to get paid. Especially what would be the bonus, what would be the incentive. Like if you're a baseball player, sign a contract, they say if you have like 100 hits a year or like 550 strikeouts a month, then we'll give you this much money. But if you don't, this much money kind of thing. So that is incentive in your contract. And of course, no baseball player would sign a contract without knowing how much exactly they are going to get paid. So you know your wage system first. Then you decide, oh, should I try hard? Should I practice hard? If you have an incentive, you would practice harder. So the wage system is first. Then the wage system was decided by principal. Principal decide the wage first. Then the agent decide based on the wage, should I work hard or not? If the president of Yonsei University said, oh, if you have like more than 100 students in your case, we are going to pay you like double your money, 200, triple, something like that. Then I would get so much student, like not 350, maybe 3,500, because I'm going to be so rich if that. But then, the president say, your salary would be basically same whether you teach 1,000 or just 10. So most of the professor has no dream of teaching a lot of students. I'm only a stupid one. That's what I am taking like 350. But something like that. So the wage is first, the effort is second. So there's timeline. First, wage decided. Second, by the principal. Second, effort decided by the agent. However, when the principal decides the wage, he should do the backward induction under this wage system, how much the agent would work in the next period. That is why this principal agent problem game theoretically is subgame perfect equilibrium concept, because wage first by principal, but principal has to backward induction under this wage, how much the agent would work. So basically that is subgame perfect equilibrium concept. And we are going to, now you understand the mathematical setup of principal agent problem. Next class, we are going to actually solve it. Okay? Be prepared. It's going to be a lot of calculation. This has been the lecture 34.